All right, quick update on the project. So there is progress made, albeit it's very slow as I try to figure out the last of the electrical package. But a couple milestones have been made. As you can see here, our manifold has a very nice heat wrap on it. It's an Inconel heat wrap from TurboSource. So the manifold, the turbo, and on the table behind here is our adapter. You can see the subframe for the rear MR2 suspension to adapt the AW11 chassis to use SW20 knuckles. Keep the geometry correct. So anyways, going back to engine here. Aside from the thermal management, we're going to be adding on an EGT sensor to the downpipe, probably around that area or abouts. We've got a couple modified items to go, so let's go ahead and dive into them. Coolant crossover pipe. Unfortunately, this one was a little bit of a learning curve, so I have to redo this. So normally this pipe comes over and goes this direction for your heater core lines, and it just means that I have to run a very long 180-degree coolant hose. Being that the car is mid-engine, both lines kind of feed over here essentially on the chassis with my setup. So I cut this, modified it to face forward, negating the need for a 180 or a U bend in the hose. The downside is I didn't have the welding skills to pull this off quite right. So this upper stainless line and the lower stainless line are brazed together. When I cut this here, I know this looks pretty terrible, but at the end I was just practicing messing around. When I cut this pipe here, I was able to weld all the way around with exception to the very bottom. I touched the brazing and my weld puddle jumped to the bottom, creating a hole. I thought, well, maybe I could just add some heat and essentially get the puddle to connect, sealing up the hole. But all it did is it just moved the hole further and further down, and now I've got an internal hole, so there's cross-talk between the two channels, which doesn't really work. So I've got a whole other one to go. So the plan is I'll cut this here and try this over again. The trick will be I'll have to do an axis panel here so I can weld the upper pipe to this section here from inside, avoiding the brazed section entirely, and I'll have a little cap that will make that weld actually workable. Coolant tee, same thing, heater return, I believe. So supply return, and those will feed back on the chassis. So these guys here. So the larger one on the left, of course, would be the coolant, and then you've got the two heater core lines. And that feeds into the existing hard lines for the MR2. You can see the firewall has been, well, actually the whole engine bay has been painted. I'm starting to kind of, put a few items back. I went ahead and modified the firewall, so I cut out a whole section to get more clearance in the turbo, and I have little threaded bosses essentially, and I'll have a heat shield that give me maybe a couple mil air gap between where the turbo is and the firewall here. More heat shielding. I'll have to probably pull that off and redo it, but aside from that, it looks good. So for those of you that aren't familiar with the AW11 chassis, this pipe here technically feeds that direction. So I've cut this off a while back and routed it this direction. So I've added this in, which is all new. And of course, that will feed up into the thermostat housing over here. So all of the routing for hoses should be greatly simplified. Unfortunately, there's a lot of them still. So we'll have our heater supply and return, our coolant return, supply. And then, of course, we'll have the 2 more for the heat exchanger. One supply and return, or vice versa. So yeah, progress, but more to go. Now, the other project in this area here is, you can see the nice little wastegate. Pretty cramped where it's at. But we're going to go ahead and scrap that one, hopefully. And I'm going to go to an electronic wastegate controller or actuator. We'll see if I can make that work. Again, more fabrication, so the turbo, of course, has got to come off to fit the engine in the bay. But I'm going to take it off and see if I can modify that to something else. So I did pick up a wastegate actuator. This is supposedly bought new from Amazon, but you can see it's not really new, at least not fully. So this one, while it technically probably worked quite well from a space consideration, there's just no way I can get that unit to fit in there this side of things. And I did think about maybe moving it along the other side, but I've got mixed feelings about having a actuator that's supposed to essentially index off of the main turbo itself to control the wastegate, have it on a different surface. So of course, you got a flange here, there could be misalignment here, much less up above, and the manifold of the engine, of course. So the further away from your control surface you mount it, the more variables and error, especially multiple components, you get a stacking error. So mounting it on the block here is probably the, least favorite choice I've got available. So I actually ordered a second one of these, but it's a unit from I think it's a VW Golf or an Audi Turbo, something or other. In either case, the unit stacks with a motor on top, and the actuator comes out the bottom. And if I'm thinking about that correctly, let's see. Of course, I can't even fit that in here. But I could fit that vertically here, and it's got an actuator that comes out 90 degrees on the bottom, facing the right direction. That hopefully will work better. But once the part comes in the next couple days, I can go ahead and try that out. So to summarize, we got to redo this whole assembly here. Thankfully I have a spare. It's not quite the right unit, but I can at least cut it up and make it work. Much cleaner welds, of course, the next time around. And then redo the wastegate to hopefully drop a diaphragm unit in favor of an electronic unit, which simplifies a whole lot, I will say. Let's see, what other updates do I have here? I think this may have been finished beforehand, but if not, it's clean and easy to look at now. So the transmission has a nice cooler, so we'll keep temps in check with that. We have this nice little wire coming down here. So there is a turbo speed sensor, and it is essentially coming off there. Downside is my clutch slave cylinder will no longer fit. So here is a unit out of a Camry, if I recall correctly. Now, everyone's going to say this is just too tight, it won't fit. Well, right now it will not fit. That is true. But not for the reasons that you'd expect. So the way I built this whole assembly, the adapter namely, if I were to clock my wastegate, which I just kind of put together without paying attention, this actually will fit absolutely perfectly with about 2 or 3 millimeters of clearance. But this part here goes right where that sensor is. So unfortunately, I will need a turbo speed sensor, which means this part will not work. There may be another option that Toyota would have, but I think I'm just going to go ahead and drop this style unit entirely in favor of something different. and that's going to be a hydraulic throwout bearing. So it'll do away with the clutch fork, and it'll have a pair of lines coming in, one for the pressure coming off the clutch. The other will be a bleed line, which allows you to bleed this thing. But essentially it'll sit around the input shaft on the transmission and push directly against the clutch. A greatly simplified solution. Does away with essentially this guy, which normally would reside inside the transmission, and this would push the diaphragm spring on our clutch, which, well, you have a new clutch. Pardon the mess, guys. So I got an X clutch twin disc. It's a 8-inch ceramic. This unit, unfortunately, will probably be a little more noisy than I care for, but I figure I'm gonna have to make some compromises somewhere, and I'd rather have a clutch that can handle power, and it's got something that's more of a gradual engagement as opposed to a unsprung 6-puck, which is what I had before. This is a whole other story. So this is a aluminum rear knuckle setup from Wilhelm Raceworks. So actually I went ahead and got new bearings for these guys, got them cleaned up very well, pressed the bearings in, but they were just a little askew, and by the time I got everything pressed in, I'm pretty sure I damaged a bearing. So if I spin this just right, I'll actually get just a tiny bit of slop. I'm not sure if you could see that on there, but I figure, you know what, if I could feel a little bit in slop, and we're talking more than a couple thou at the hub, that's probably going to be a 1/4 inch at the wheel. So I have to do that over again, but these bearings are not cheap, and if I did any damage in the bores, I pressed them in, that means the hub itself is probably toast. Maybe not, but I'd rather not risk it with what I'm trying to do. These are known to potentially break under hard track use, high grip tires, a lot of lateral G loading, and I think there's a bit of a weakness here. I certainly know the front hubs are more known for that issue, but I figure we'll play it safe. This is an option that's available. A nice billet aluminum knuckle, and yeah. We have a cartridge style bearing and hub assembly that's actually more reasonably priced than the factory press-in units. Figure why not? Let's give it a shot. So we'll see how that works out. Let's see what else to say we got on this thing. So the oil coolers are off getting serviced. Sorry for moving the camera around a lot there. The little factory beehive coolant to oil cooler, more of an oil heater in reality. So that'll come back, I think, the next couple days or early this next week. It's been cleaned by Pacific Coast Oil Coolers. They do a lot of oil coolers for aircraft and aviation, so it should be pretty good. We'll get that back on there. We've got a sandwich plate from Greddy. This is a thermostatic sandwich plate, so it intercepts oil flow into the filter and sends it off on these ports here. So I'm not sure just yet if this is the feed or return, but the opposite side will be feed or return, the opposite essentially of the other. So we'll have these lines going off to a much larger air intercooler or heat exchanger that's going to reside here. And I wish I could show you pictures of that, but the unit's off, getting cleaned. But made this large bracket, and that essentially is going to hold another bracket, this guy. And this guy holds, I think it's a 10 by 7 by 2.5 inch heat exchanger, and that's going to have essentially an air oil cooler. So, of course, the engine sits, turbo towards the firewall. So these lines will come essentially over and up, and right about here will be a large heat exchanger for oil. thinking this whole process through, being that the oil cooler was going to be essentially the same height as the head, and I've got a port on the top and a port on the bottom. The concern was when the car's not running, all the oil is going to drain back to the pan, and you check the oil in the engine, and of course it's going to be overstated. Don't want that. That's just nonsense. Conversely, the next time this thing turns back on, you're going to have to fill up the heat exchanger where the oil flows back into the system, and I don't know, I think it holds 1.7 liters of oil. Not only is that a whole lot of oil to sit in excess on the pan, but that's a whole lot of oil dwell time to flow through this system to supply, and I don't want to have oiling issues at all. So actually, kind of a neat little solution. This is a check valve. It's a nice little machined unit, and it allows oil to flow through, or fluid to flow through, in this case it would be oil, and not come back. So one-way valve. So that's going to sit on either one of these. It'll be on the feed line, and that'll go to the lower heat exchanger, and then all the oil that sits in the heat exchanger will stay in the heat exchanger and not in the pan, which will make me a happy camper. Keeps the oiling level in the pan consistent, and then the cooler itself will not have dwell time to fill up with fresh oil. It'll already have oil, which will be cooling and provide immediate relief to the engine. So thermal management and capacity should be greatly improved. So very happy with that solution. Let's see. So I think what's really caused the biggest delays with the system is what I'm trying to do. Here is essentially where the ECU is going to mount on the firewall. So it's an EMU black. These things are actually a pretty powerful little unit. If I weren't trying to push the technology as hard as I am on this, that would absolutely be perfect. The shortcomings on this, I think, were probably going to be with regards to the traction control strategies. As my understanding is limited on this, I think it really just does a boost cut, or not a boost cut, pardon, an ignition cut. And that works, but it's hard on the engine. So what I've learned is there's opportunities out there to do a different control strategy where you can limit boost levels, regulate throttle input, and have that control engine torque to make your traction control work, with the last step being ignition cut. So from a torque management perspective, which the whole philosophy of this build is going to be, because it's a lot of power in a small car, is just managing the power. Motec ECUs have the means to do that. So I'll get some reliability out of the engine and have a very, very robust traction control strategy, which will allow the engine to actually live. I can also do some other things to ensure that the blocks aren't the strongest on these things. I don't know all the details about it, but I think the stud pulls out of the block if the cylinder pressures get too high. So again, I should be able to limit that to some degree with this system. So essentially the wiring harness, which has been sitting here, has been on pause while I kind of work out the rest of the sensor package and making sure that I can use the Motec ECU. Of course, there's a lot of inputs and outputs in the thing, and yeah, I'll probably have to add in maybe another dozen wires or so to this, so I gotta undo all of this and try it again. But at least I can reuse the bulk of the harness, spare these guys. And what else do I have? Other things to mount and do. Got a nice fuel filter. So this is a unit from Injector Dynamics. It's a nice cartridge style filter. Click this, cartridge can spins off, the element inside is replaceable. It's got a flow meter so I can actually see as the filter becomes clogged with use when it's time to replace it. So essentially maximizing part life. The other thing I have to mount somewhere in the system is this guy here. I'll mount this probably on the return side of things, and that should work out okay. Other part installs, well, this is a CAN bus keypad, so that'll work with the PDM unit to control a lot of these systems. But yeah, essentially that's the high-level update. Everything is primarily focused around getting the engine and electronics package working the way I want. So more to come on that project. A couple other things in the works. Pretty excited about what the future's going to hold, but right now, yeah, the excitement level is getting pretty high. I just want this thing going, and I want it going, hopefully, how I envision. But time will tell. If all else fails, I'm having fun, and can't complain about that. But it is nice admiring the engine on the stand here. Worst case scenario, sit back, crack a beer, and kind of dream. God, that looks good.